Okay, so now that we're back on the 255, an IP address ending in 255. Again, this is not a host. It's not a host, but instead, if PC 1.37, this guy sends a packet, and you look at the destination of that packet, and it says 192.168.1.255. I'll ask you one more time, maybe you know it. What does that indicate it wants to do? If this PC with IP address 1.37 sends a packet to destination 1.255, what does that mean? Johnny? Oh man, you're like 2 steps ahead of me. It could mean that it wants to join the network. And I'll come back to that. Yes? What does it mean? It wants to broadcast on that network. Now, based upon that, why did Johnny, and he's right, why did Johnny say that if PC 1.37 sent a packet out to 1.255, why is he saying that it wants to join that network? Did I have that right, Johnny? Why is he saying that it wants to join that network? Yes?
When somebody joins the network, they broadcast to the rest of
It broadcasts out. That's exactly right. When I want to go get an IP address to a DHCP server, I broadcast out a message on that network that says, hey, does anybody have a valid IP address for me? And then the DHCP server comes back and says yes. Okay, it comes back and says yes. But it's not necessarily just DHCP. It could be a broadcast for some other reason. It could be a broadcast to say, is there a DNS server out there? And we'll go through that when we get to the server side. So anytime you have a destination ending in 255, that means it's broadcasting on that network. Okay? If it sends out a packet on 192.255.255.255, then it's not only broadcasting on its own network, but it's also broadcasting on any other networks that are connected to it. Assuming, that will work, assuming that this router allows for broadcasts. Okay? And if you remember right, the first 9 weeks that we were covering the purpose of routers, we said that one of the benefits of having a router is it cuts down on broadcast traffic, right? Because nobody else can talk when somebody else is broadcasting. But there are sometimes legitimate reasons for broadcasting across a router. And so most routers will have the ability to send broadcast messages for certain types of traffic, like DHCP. Let's say, for example, this server didn't exist, and all we had was a few PCs on this side of the network. Well, this PC still needs an IP address. This one here still needs an IP address. So if you configure it this way, network administrator, you can tell this router, accept DHCP broadcasts only, and forward them to, I don't have a server over here, forward them to a server. Okay? And so that server will answer it, but that's the only type of broadcast traffic it will answer to. That's entirely up to you how you configure it. Again, when we get into DHCP, we'll go through that. All right, so here's what I want you to do. We have a group of students, we have a group of 4 there. We now have a group of 4 back there with Gabe and Christopher. We now have a group of 5 on that side of the table. We now have a group of 4 right here, and then from Jordan over here we'll have another group of 4, and then we'll have a group of 6 over here. Because looking at this group, we're probably going to need all 6 of you to get the right answer. Okay? Was that cold-hearted?
No, good.
All right. You owe me 2 laps around the big dog for criticizing. All right, so here's what we're going to do. I'm going to make a drawing up here. I want you to replicate that drawing as a group. You will have exactly 10 minutes to give me an IP addressing scheme for every device on that network. And then you as a group will present, hey, listen. And then you as a group will present that IP addressing scheme. So we have, hold that thought, Austin, we have 1, 2, 3, 4, 5, 6 groups. Now, what's your question?
So each person is a PC, right? Or each
I'm gonna make a little drawing. Just hold tight, I'm gonna make a drawing, and then you're gonna replicate that drawing, and you're gonna assign IP addresses to it. Okay? All right, here's the drawing. You ready? PC1. Get this stuff up here. This is a switch. Pay attention, please. Which means don't talk. You have a switch. You have a printer. You have a server. You have a router. You have the ISP's router. And then that goes out to the internet. Okay? I want an IP address for PC1, for this printer, for this server, for this router, anything that's appropriate for that router, and for this router. Everybody understand the problem? Work together on it. Make sure you always pay attention to what the rules are. Work with your group. Yes? But hey, guys, the only other thing, just keep it down to Dole Roar. Yes. That's the ISP router. I want fully functioning devices on this stuff.
Yeah. Pull up on
Oh, God. People who are as technically proficient need a translator. I want a fully functioning, I want every device to you guys start doing these two.
This is still this word is router. Right here is where it splits.
You have 7 minutes.